Hi, my name is Robert Luciani, and I'm a computer scientist and partner at the AI Framework. I've been doing data-driven transformation for a long time, with customers ranging from the Swedish Central Bank to Ericsson and IKEA. I use very many computers in my daily work, and what's most important is that they make me efficient and make me more inspired. So today in this short video, I want to show you how I use this computer to make myself more efficient and inspired. Let me show you. Now, a lot of decision makers out there think that you need lots of IT infrastructure in place to even get started with AI development. This simply isn't true. And I want to show you just a fun little demo to exemplify why this isn't the case. I'll go ahead and open up Visual Studio Code here, where I can show you a bit of Python code. This particular code here loads a version of GPT locally on the laptop so that we can program towards it, query it, just like you would against an enormous service hosted by OpenAI or Microsoft or whatnot. And so with this medium-sized GPT model running on the laptop, we can now query it and ask it, a data science workstation should what? Let's go ahead and ask. Boom. A data science workstation should be able to handle it. I think that's fair, but all right. Let's get to some more technical demos here. All right, so this demo here is pretty neat because it shows exactly how much performance is available in a machine like this, provided you want to put some engineering effort into it. So let me show you here some simple Python code whose purpose is to find how many times the number 42 is evenly divisible by every number from 1 to 100 million. If I go ahead and run this now, you'll see that it'll think for a couple of seconds and spit out an answer. And your first thought might be, how can I make this faster? Well, if you ask any Python programmer, they'll tell you one good way is to use libraries that are written in a very performant language such as C++. In this case, NumPy is a library like that. And so we can run the same calculation again except on a NumPy array and see what happens. And so your team is sitting there spending a lot of time and effort trying to make your libraries run fast on your poor hardware, and well, what's going on? It's not running faster. What's wrong with this machine? It's so slow. Look at that. It ran in 5.7 seconds instead of 2.8 seconds. There has to be something wrong with the machine, right? No. Now, in principle, this could be done in Python or any programming language, but Julia makes programming so enjoyable, I prefer to show it this way. Let's go ahead and run the code again. And recall that the Python program took about 2.5 seconds using a list and 6 seconds using NumPy. What Julia is going to be doing here is using all of the cores on the processor and also SIMD vectorization. And let's see what the difference in time is. 0.2 seconds. Now you might be thinking to yourself, that doesn't sound like a big difference. Well, let me tell you, it's a huge difference for a very important reason. Again, imagine that the calculation above took 6 hours or 2.5 hours, and now all of a sudden is down to 20 minutes. But we're not quite done yet. Let's see if we can get even faster. I told you before that this laptop has a GPU in it. When you program with a GPU, you have to express your problem in a form that's amenable to GPUs. Again, it's outside of the scope of this video to explain how GPU kernels are written, but Julia makes it very easy to express things in a parallelizable way, so I'm simply going to run this cell and exemplify the same code, except now it's running on the GPU, and we're going to see how fast it is. 0.15 seconds. So we went from 2.5 seconds to 0.15 seconds. That means that if before you were waiting 2.5 hours for an experiment to run, now you might be waiting 10 minutes or something of that sort. And here's the question. How many experiments would you afford yourself if you could run something in 10 minutes, which would normally take you 2 hours or 5 hours or whatnot? I'd say quite a lot. Which leads us to our last demo. Now, something we do a lot as data scientists is visualize data, and again, I'm going to exemplify using Julia, but if I take a random array and visualize it like this, I can get a beautiful rendering, pixel perfect, with screen space ambient occlusion, and even ray tracing, and have it run locally here on my machine to explore data. Good luck doing that over the web. Now here comes the corporate deployment part. With Windows Subsystem for Linux, I can actually have a real version of Ubuntu running at native speeds with super fast disk access, super fast network access, and GPU acceleration. This version of Ubuntu is running on Windows with a real Linux kernel. Let me go ahead and show you. NVIDIA SMI. As you can see, CUDA version 12 is working just fine in Ubuntu on Windows. I even have a couple of Wayland programs running in the background. And so you can be doing all of your development in Ubuntu on your Windows machine on a managed PC. And the last piece of the puzzle here is having Docker Desktop. So you develop in your local machine in a Docker environment and then deploy to your Docker and container deployment environment in the cloud afterwards. That is a pretty sweet development setup. Well, there you have it. There's only so much I can show you in 5 minutes. I hope you thought it was a bit of fun. And if you want to know the specs of this particular machine, I'll include links in the description below. See you around.